Greetings, I'm Professor Hobo, and welcome to another HOBOTECH News product review. Pecron is known for their inexpensive portable power stations, and none have been more anticipated than their new flagship behemoth, the E3600 LFP. It's got a full 30 amps or 3600 watts of pure sine output, can be paired together for 240 volt split phase service, and has not one, not two, but 3 solar controllers built in. It's also premiering at a crazy low price of only 42 cents per watt. But there's really only one question that we need to have answered. Is it any good? Let's whip out our Pecrons and find out.
HOBOTECH.
For those of you that like really big Pecrons, they don't get any larger than this, as inside the 3600 LFP is a whopping 3072 watt-hour lithium iron phosphate battery rated at 3500 cycles or 10 years of daily use. This is actually expandable with up to 4 additional 3 kilowatt hour external batteries through these ports to provide up to 15 kilowatt hours of storage power. Now, that's almost a full day's amount of power for the average home. As for size and weight, it's 17.5 by 12 by 14 inches and only 79 pounds. And this means that even with my broken back, I can still pick it up by myself. Nice. The display is a color touchscreen, which I thought at first was only grayscale, but once you dig into the options or approach overload conditions, you'll actually start seeing some color. The only 2 physical buttons are the AC button and DC button, which also double as power buttons. Now to turn a unit on, you just press either one of the AC or DC buttons, hold it down for a few seconds, and the screen comes on, system fires up. There is no separate power button. Now what's good about this design that even if the touchscreen were to fail, you can still fully use the power station by using one of these 2 buttons. It also does have a remote app that you can put on an Apple or Android that in fact allows you to change the settings and operate the unit remotely without using the screen at all. The 3600 in the name is of course the size of the inverter. It rocks a 3600 watt pure sine with 4 20 amp outlets and a TT30R 30 amp hookup that, unlike many other products that offer a 30 amp outlet, this one actually outputs the full 30 amps. Now, the 3600 comes with a proprietary AC charging cable that automatically limits the grid charge to 15 amps thanks to the little data pins built into this aviation connector. Now, this allows charging up to 1800 watts from AC power, good for topping up from 0 to full in about 2 hours. And with the optional 30 amp charging cable, you can charge up at 3200 watts, letting you top up this SoGen in about 1.3 hours. Inside both the app and on the settings on screen, you can change the charge rate from 10 to 100%, allowing to charge from outlets that may have limited wattage like an inverter, like in your car or truck, or from a gas or propane generator. Now this product rocks 3 separate solar controllers, 1, 2, 3, for a maximum charge rate of 2500 watts. First controller on the far left is low voltage that enables charging from 12 to 30 volts through a 7 amp 5521 barrel plug, and then next to it are 2 high voltage MPPT controllers that can charge from 32 to 150 volts at 20 amps using XT60 connectors. Now at 2500 watts, this thing can charge the Pecron in about 2.5 hours under ideal conditions. And Pecron does provide these 2 MC4 to XT60 connectors, so you can use both of the solar controllers on it. Last and certainly least, the 3600 can car charge from 12 or 24 volt sources, including vehicles or external batteries, up to 150 watts using this included car adapter. Now this hooks into the 5521 barrel plug and is hard limited to 7 amps. At 12 volts, it takes about 34 hours to charge this way. As for 12 volt output types, the Pecron offers 3 12 volt outputs. First being, of course, the standard cigarette lighter socket, good for 10 amps. Second is a 5525 barrel output, good for 5 amps. Last is the coveted 30 amp 12 volt regulated output via XT60EF connector, which is an interesting choice and one I don't recall seeing before. Also an interesting choice is the optional cable you can purchase to use this 30 amp output. It actually has battery clamps on it, and I assume this is to charge a battery. I would think they'd offer something more common like an Anderson power pole output, because that's what everybody else does. But Pecron is being Pecron. In fact, the XT60EF is so rare that I didn't have a single cable in my inventory to use for testing this output. So I hacked off the battery clamps on one of the cables and put Anderson connections, which I use for the majority of testing my devices. As for USB outputs, the 3600 does offer 4 USB-A quick charge ports, a single 18-watt USB-C port, and a single 100-watt USB-C power delivery output. While everyone else seems to be getting rid of these, I am happy to see Pecron does in fact include a pair of 15-watt wireless quick charge pads up top. Do note that in order to use those wireless charging pads, the entire DC circuit needs to be on, which does consume quite a bit of background power. How much, we're going to find out here in a moment. As previously mentioned, it does support battery expansion ability up to 15 kilowatt hours for each unit via the built-in pair of bidirectional battery ports. And 2 of these big Pecrons can be hooked together to form one massive 7200 watt beast capable of 240 volt split phase output. This is enough inverter power to run virtually any appliance in your home, including electric ovens, dryers, well pumps, and water heaters. I'm going to demo how to double up your Pecrons here in a moment. As for the warranty, Pecron offers a very sweet 5-year manufacturer's warranty on the E3600, which is something we usually don't see outside of the major brands, and it's nice to see Pecron stepping up their game here. And of course, I whipped out my Pecron here in my secret laboratory where I performed all kinds of crazy experiments on it, including, yes of course, let's all say it together now, a double-fisted bang bang battery capacity test. As for the results of the DC battery capacity test, it scored 2,650 watt hours out of 3072 for a respectable 86%. Note that this test was ran using the 30 amp DC output running at about 20 amps. I also ran this test a second time at 10 amps to see if I got a different result, and I did get a slightly worse result of 2,590 watt hours, and this difference was mainly just due to the test taking twice as long at 10 amps. Okay, it's been 2 days since I did those time lapses, and something happened to the 12 volt side of the Pecron. And that is, if you can see it there with all the reflections, 12 volt voltage is 0, output power is 0. This is 0. Nothing is coming out of the DC output anymore. It's completely dead. Of course, I contacted Pecron about this and I let them know about this problem. They said, oh yeah, they're engineering samples and we rushed them out to you and they weren't properly tested. And I said, what do you mean they're engineering samples? I am not interested in beta products or alpha products or engineering samples. I want finalized retail products that customers are going to get. So they told me after the fact that it's going to be fixed in the retail version and that they've tested it thoroughly now in the past couple of weeks since they sent this to me, and they're not seeing any problems with it. But I need to report to you what I find. And what I found is that the 12 volt circuit on this most likely overheated and burned itself out. Because here's what I did. I did 2 time lapses on the 12 volt circuit because I did a first time lapse at 20 amps. So I ran it a second time at 10 amps using a different shunt. So 2 different pieces of equipment, 2 different time lapses, 2 different rates. I got almost identical results. Within margin of error, the results are pretty much identical. So the DC result is actually the DC result. When I charged this thing back up and went to turn it on, the DC output did nothing. Because I was going to show you guys next, it was 12 volt regulated, right? So I put this in and I went to turn it on. I was like, it's not doing anything. And it even shows 0 volts on the screen. And I says, well, this isn't normal. I let the whole thing cool down overnight and I came in, still nothing. It's been 2 days, still nothing. So it's definitely not an overheating issue. But I'm guessing that the 12 volt circuit itself overheated, burned up, and therefore doesn't work. So I do need to report this stuff to you guys, even though it's an engineering or beta test model. That doesn't mean that the final version is going to have this problem. It doesn't mean that the version you buy is going to have a problem. I mean, at least it shouldn't. I gave them the option to send me a retail version in a couple of months and I'll retest it because I don't have time to just wait another week or two for another one to come in and redo all these tests. I got other videos to produce, so I got to get this thing out now. If I do get some updated information after this video comes out, I'll do a YouTube short or something, let you guys know that, if there's any changes to this issue between now and then. As for the results of the AC battery capacity test, it scored 2,770 watt hours out of 3072 for an above average 90%. Not bad for a 30 amp inverter. Of course, we performed a phantom load or parasitic drain test where you left the DC and AC circuits on for a period of time and extrapolate how much power it would take over 24 hours if you just left the thing turned on. DC consumption used 184 watt hours over 12 hours or about 368 watt hours over a 24-hour period. This means the DC side consumes 15 watts for as long as it's turned on like you see it right now. Now, as for AC consumption, it used 185 watt hours over 4 hours, or we extrapolate that out to 24 hours, it used about 1100 watt hours. This is about 46 watts for as long as the inverter is running. That's quite a bit of loss, but recall this is a pretty big 3600 watt inverter. The bigger the inverter, the more power it's going to waste sitting at idle. So if you left this inverter on under no load, it would totally kill the battery in just under 3 days. Now, I'm always asked how long stuff's going to run on these power stations, so compensating for capacity, which we just found out in the previous results, you can pause this chart on screen, and it's going to tell you approximately how long certain appliances will run on this unit. Pure sine wave check under load. 120 volts, 60 hertz, good sine wave. Inverter capacity test. This is where we determine how far can we push the 3600 watt pure sine inverter on the Pecron. Okay, you're looking at the watts right here. We're going to start at 3600 since that's the base for the inverter and work our way up. 3800, 3900, 4000, 4200, 4400. It looks like at 4400 it craps out. I'm going to redo that one. All right, 3400, 3500, 3600, 3800, 3900, 4000, 4100, 4200, 4300, 4400. Okay, 4400, I would call it 4400. This next test is the 5-minute sustained cooling or heat soak test where we run the inverter on this at its maximum capacity for at least 5 minutes to make sure it doesn't misbehave. And by misbehaving, we mean smoking, drinking, BO, smelling funny, driving too slow on the freeway or passing in the slow lane or any of those things that would be considered misbehaving. What we're really trying to find out is, can this thing handle 5 minutes at its maximum capacity without having any problems, without giving off any foul or noxious odors, or fans making funny noises, or it just not being able to handle it. So I have it running at 3640 watts. I'm going to go ahead and start the timer. The sine wave and everything still looks pretty good over there on the oscilloscope. And we're going to let it run for 5 solid minutes and see if we run into any issues. And there we go. We'll come back in 5 minutes and see if it made it. And FYI, if you go into the settings, you can actually see the wattage, the voltage, the frequency, and the temperature of the inverter on this ancillary screen here. Okay, here we are coming up on 5 minutes. No problem, no funny smells. The oscilloscope down here shows everything's just fine. Everything up here is reporting fine. Out of curiosity, the inverter is running at 125 degrees Fahrenheit, which isn't bad at all for being at maximum capacity. Everything else looks good. The voltage did drop to 115 volts. It says 116 over here, but that's perfectly fine and acceptable. The sine wave is still perfect, and that's what we want to see. So just how loud is it under maximum power from 1 meter away? So 52 to 53 decibels, not too bad for this thing being at full blast. About the literal elephant in the room here, yes, I have 2 of these Pecron LFP 3600s because you can combine 2 together to make 240 volt split phase service. Now, for those of you that do not live in the USA, 240 volt split phase service is not the same as your 240 volts that you have in Europe and Australia and other countries. This is basically two 120 volt systems that combine together with the same frequency in order to make 240 volts, but it's still two 120 volt circuits that oscillate to make 240 volts. That's the simplest way I can explain it to people that don't understand electricity. So the first thing you obviously need to do is double your Pecrons, and then get the double voltage hub, which plugs into the 30 amp on each one of the power stations. And you have to use this data cable, which looks like a basic Ethernet cable, between the two data ports. So there's a data port on the left side of each. The 30 amp is right there, so let's go ahead and hook this up right now. And all that data cable does is synchronize the two inverters, because the two inverters need to pump in an oscillating fashion in order to make 240 volts. All right, so now what we got to do is turn on the AC inverter for both units. It will have a green light right here. It says status green OK. And there it is, status green OK. That means we should have 240 out of this middle one, which is basically, again, two 120 volt circuits combined inside of here. So unlike other double voltage hubs, which gives you 120 volt outputs, this one does not. Both of these are 240 volt each, and then this one's also 240 volt. Now the difference between the middle one and these two is this is a 4-prong twist lock. So you have two 120 volt lines inside of there, which are combined to make 240. The two hots on both of these outlets are straight up 240. There's no way to get 120 out of that. Now, I'm not actually going to do a load test on a 240 volt system, because all it's going to do is double the inverter for each one. So we already know the maximum is 4,400 watts for 5 seconds on each inverter. So combined, it would be 8,800 watts for 5 seconds. And of course, each one can run 3,600 watts continuously, which would give you 7,200 watts combined in a 240 volt system. But what I am going to do is plug in my 240 volt compressor to prove to you that this not only works, but it actually will start a compressor. But what I want to do before I plug any equipment into this is make sure it's 240 volts at the right frequency, because I don't want to blow up my compressor. So there you have it, 241 volts at 60 hertz. The sine wave, again, looks perfect. And what we're running today is this California Air Tools 240 volt 10 gallon air compressor. So let's go ahead and plug it in right into the 240 volt line and turn the power on. And there we go, no problem. So you can see here it says 587 watts, and it's the same on this one. So what it does is it splits the load. So it's doing about 600 watts on this one and about 600 watts on this one. So there you have it. It will run a 240 volt air compressor, no sweat. Like I said, when combined, this should be able to handle up to 7,200 watts. That means it can run your clothes dryer, your electric water heater, your electric stove, your electric well pump, no problem. All those are well within 7,200 watts at 240 volts. Okay, so you may be wondering, while this is in 240 volt split phase mode running your appliances, can you charge these power stations with AC power? The answer is no. You can't charge it with 120, you can't charge it with 240. When you're in this mode where both inverters are synced, there is no AC input. The AC input completely turns off. So don't think you can use this as a UPS mode for 240 volt appliances. You cannot charge these power stations with AC power when you're in this mode. Now, that being said, you can charge them with solar, and that is no problem whatsoever. You can charge each one with the maximum amount of solar. So you can do your 2,400 watts on this one, 2,400 watts on this one at the same time, and top up the batteries that way. So there is a way to charge them, just not with AC power. And yes, of course, there's no UPS mode when this is available as well. So one of the cool things about the Pecron 3600 is that it doesn't have just one MPPT solar controller, but it has 3. Now, one of them is a low power input meant for a single solar panel or charging from 12 or 24 volt vehicle. That one is the one over here on this side, which uses a 5.5 millimeter, and that supports from 12 to 30 volts at 150 watts maximum. So like I said, A single solar panel, 150 watts or less. Or you can plug this into a car or truck, or even another 12 or 24 volt battery and charge it through that port. Now the big heavy hitters are the pair of 1200 watt MPPT controllers. Those start at 32 volts and work their way up to 150 volts. For people that don't understand voltage, that means a minimum of 2 solar panels in series or 1 large residential panel in order to meet that 32 volt minimum. So we're going to test all 3, starting with the small 150 watt one first, and for that I have my small little variable voltage charger down here. So here you can see it says 12.7 volts at 7.4 amps and 93 watts. So you'll get about 100 watts of charging through this port if you're charging it from 12 volts. So let's go ahead and take it up to 24 volts. Okay, there we are, 24 volts, about 6 amps, and we're already hitting the maximum 150 watts. So this will allow charging up to 30 volts. I don't expect it to do anything else. So we're now pushing it to 30 volts, 5 amps, 145, 150 watts. Let's see how far we can push it. It should give me an error message once I exceed a certain voltage here. 31 volts, 32 volts, and then the power drops, and then you get this error message that says charging input overload or over voltage. So let's drop it back down to under 30 volts. You can see everything is back to normal, and it will start charging again. So it is a self-correcting solar input, which is fantastic. You don't have to turn the system off and on again to get it to reset. It does it automatically. That's a very nice feature from such a cheap power station. I'm gonna unplug one of these inputs here, so we're only using the 1 MPPT controller. Remember, this is a minimum of 32 volts, so let's take it down to 32 volts. Even though this is a power supply, I mean, it acts just like a solar panel, so you're going to get the same results. Okay, going from the bottom up, we're now at 30 volts, and there it goes. It actually starts to charge at 30 volts, not 32 volts. Let's see what we get at 30 volts. So 30 volts, 18 amps, 520 watts. That's not bad at all. Let's go ahead and take it up. 32 volts, 18 amps, 570 watts, so not too much difference. Let's go ahead and take this up to 48 volts, which would be 2 solar panels in series or a 48 volt battery bank. Okay, 48 volts, 18 amps, 860 watts. 60 volts, 18 amps, 1100 watts. So we're definitely getting up close to the maximum of 1200 watts pretty quickly. Okay, let's take her all the way up to 150 volts. There we are at 150 volts, 8 amps, 1166 watts, around thereabouts. So that's what we expect. It's a 1200 watt maximum on each one of these MPPTs. It starts all the way down at 60 volts. So the fact that the maximum wattage for the solar input starts as low as 60 volts is very good. That means you can do series, parallel, or series parallel connections with your solar panels. And as long as you hit that 60 volts, you can max out the controller at 1200 watts. So this thing takes quite a bit of amps. So according to the manual, each one of those MPPT controllers, the high voltage ones, can do 20 amps. So that's the maximum limit for a 10 gauge PV solar cable. So that's great that this takes the 20 amp maximum up to 150 volts. That means you have no problem whatsoever getting 1200 watts out of each one of these. So now I'm going to do something a little different that I haven't done before, because I don't have multiple chargers that can do 150 volts. What I'm going to do is I'm just going to go ahead and parallel 2 outputs out of this into this, and we'll see what we can do. So this thing can output 4,000 watts. It should be able to hit the 2,400 watt maximum on this without too much difficulty. But the problem is this is limited to 20 amps, so it can't output more than 20 amps. So let's see what it can do. And we're just going to start at the maximum 150 volts and see what happens. 2,000, 2,200, 2,300, 2,330. All right, so it looks like 2,360 is about the best we can do with those 2 solar controllers, but can we include this one as well? So let's go ahead, and I'm going to go ahead and turn this sucker on too at the same time by plugging this back in to give us an additional, hopefully, 150 watts. So check this out. You got your 150 volts, 8 amps, 150 volts, 8 amps, and then over here you got 30 volts at 5 amps for a grand total of 2,500 watts. There we have hit the magic 2,500 watt mark. with all three MPPT controllers taking their maximum power simultaneously. So there you have it. All three MPPT controllers can be run at their maximum simultaneously for a massive 2,500 watts of solar input. Very impressive, Pecron. Now next are the AC charging tests. Now here's something that a lot of you are going to poo-poo on about Pecron. They decided to go with a proprietary connector. If you take a close look at this connector, you can see those two pins in there. Those are data pins. So you have your hot, neutral, and ground, and then you got these two data pins in there. And what these data pins do is it tells the Pecron which one of their cables that you're using. So you can't just pick up one of the $3 cables on Amazon. If you break the AC charging cable, you have to buy it through Pecron. I know a lot of you are going to poo-poo on that. But what this does, this allows you to plug in the 15 amp cable and it will automatically limit your charge rate to 15 amps. So what I'm going to do is charge this from the wall at 15 amps and then run all the solar at the same time to see, does this support simultaneous charging? Now it should, because virtually all modern power stations do, but you never know, so we do have to test this. Now what's cool about the 3600 is that not only can you change the charge rate through the app, but you can change it right on the touch screen. So you can see here, you can go from 100% down to 10% charge rate. At 100%, we get about 1,700 watts coming in. So let's go ahead and change that. Let's do 50% just to see, is it actually 50%? There it is, 900 watts. That's half of 1,800, so that's actually working. Let's change it all the way down to 10%. Again, I just want to make sure that it's doing what it's supposed to do. Quite interestingly, it charges at 400 watts, which is definitely not 10%. So yeah, a little bit of a math issue there, and for some reason they don't actually have it set up with correct percentages. Now the 50% seem to be fine at 900 watts. So I'm not really sure why it's not doing 180 watts or 200 watts or so at 10%. Then again, it's a good thing we test these things. Maybe this is something they can update in firmware, because I know a lot of you are going to want to charge this thing at a slow rate from the wall. And I know some of you may be disappointed here because it looks like the lowest charge rate we can attain from AC is 400 watts. Now that might be a little bit too much for some of you that have an inverter built into your vehicle. A lot of SUVs and trucks and everything now have inverters built in, and usually they're limited to 200 or 300 watts. Sometimes you can get them a little bit bigger. This is a minimum 400 watts, so unless that inverter is at 500 or 600 watts, this isn't really going to work. So maybe that's something they can patch in firmware. We'll see. What we're going to test now is simultaneous charging. Let's pump the maximum amount of solar in and see how fast this thing charges. Okay, we ready? I'm going to go ahead and plug everything in that we got. 2,500 watts of solar and 1,800 watts from the wall. You can see two numbers here. You got solar at the top and AC at the bottom. So you see something interesting happening here. The solar is maxing out at 2,500 watts, and then we're only getting an additional 800 watts from the AC wall power. It seems as though this has a hard limit of around 3,300 watts of charging, because it's only allowing 800 AC from the wall and 1,500 from solar. This has what we call solar priority, where it pushes away AC power to make room for more solar. So this is a more green solution, because if you have AC and solar at the same time, it prefers solar. So now watch as I turn the solar off. The AC power should come back up and take over again. There it is, pretty quickly. It goes right back up to 1,800 watts from the wall, and I still have the one MPPT turned on, so it is allowing a little bit of solar to come in as well. So there you have it. It does support simultaneous charging up to 3,300 watts. That's 2,500 watts of solar with 800 watts maximum AC simultaneously. So this can charge very quickly, less than an hour, probably about 45 minutes from dead to full if you were able to do this magical 3,300 watts of charging. So just how loud is this AC charging? It's not loud at all. 44 decibels, that's pretty quiet. So what if you're in a campground or some other place where you have access to a 30 amp hookup? Well, you can get this optional cable from Pecron that will allow you to charge up to 30 amps. That's pretty darn fast. Now with the 30 amp plug hooked in, we are now charging at 3,400 watts. That will top up the Pecron in about 45 minutes. That's just crazy. Let's go into the AC charging speed settings and now see what happens if we turn it down to 50%. Okay, it drops it down to about 1,560 watts, so that's about 50%. Now let's go in. And with a 30 amp cable, it drops it down to about 550 watts. So if you have it set at 10%, it charges still way too fast for being 10%. 10% of 3400 should be 340 watts. So it's charging about twice as fast as it should be. Charging at the minimum 400 watts, it drops the decibels down to 43, so even quieter. So the most controversial test on solar generators on the internet seems to be the UPS test. Everybody complains that I don't ever do it the way they think I should do it. But we have a full PC computer here running a music video from YouTube at 1080p. It's pulling about 80 watts of power, so it's under load. It's a full PC, everything's good to go. Now the Pecron claims to have an 8 to 20 millisecond UPS mode. UPS stands for uninterruptible power supply. That means if you have your computer plugged into this and the power goes out, then the computer keeps running. So right now I have this switch box plugged into the wall. So we're charging the battery at 1000 watts, laptop's taking 70, you see a music video playing. As soon as I push this button, it cuts the power off to the power station, and we'll see, does the switchover time go fast enough to keep this desktop computer running with a load? Place your bets. 3, 2, 1. Well, the lights blinked in the room, but it didn't actually do anything to the computer. So there you have it. UPS mode works 100%. The 3600 does offer the coveted 30 amp 12 volt output, which is regulated. We're going to go ahead and push it to its max to see if we can get at least 30 amps out of it, which would be 360 watts. All right, we're watching this number right here that says 0. That's going to let us know how much power we're pulling. All right, wow, we actually spiked it there to over 400 watts for a few seconds, and it actually says the word max. You can see that there, it actually says the word max when it goes over. You're not supposed to really pull more than 30 amps from this, but it does look like it can handle 30 amps no problem. Next test cigarette lighter socket. Looks like it's regulated at 13.5 volts. Let's see how many amps we can pull. 10 amps, no problem. Still holds a rock solid 12.9 volts, so that is a good outcome. So the Pecron does offer a single 100 watt power delivery USB port. We're not going to test any of the other ones. They're all just basic ports. We always make sure the power delivery works because that's the one you're going to be charging your laptop off of. So I do have a power bank here that accepts 100 watts. Let's see how it's charging. There we have it, 103 watts from the USB. So not an issue whatsoever with the single 100 watt power delivery port. We do have a pair of wireless charging pads up top. My phone supports wireless charging. Let's go ahead and see. It does say fast charging, 1 hour and 43 minutes from 30% to full. That sounds about right for fast charging. So it's not a super fast charger, but it is a fast charger. Musician's favorite amp interference test. This is where we determine how clean or dirty is the inverter for running a power amp, ham radio gear, PA system, anything like that. So place your bets. Is it clean or dirty? I wouldn't say it's the cleanest inverter I've ever heard, but it's also not noisy. I think the noise coming through that speaker is minimal. So while it's not perfectly clean, I would say it's 90% clean. And just to give you a comparison, this is now plugged into the wall, so listen to how much cleaner it is. So you can tell there isn't that little tiny bit of buzz in the background like there was coming from the Pecron. I don't think it would bother most folks, even in a PA system setting, to hear that. Although a musician, if you're using recording gear, you're probably not going to want to use the Pecron because that noise is likely to come through while you're recording. But I think in a performance setting, I don't think anybody's going to notice it or care. AM radio interference test. This is where we put an AM radio and turn on the button. Played a little song there for us. Now notice that I turned the power station off, but it's still causing interference. There is no on and off power button on this. When you turn off the DC or AC, that just powers down the power station, but I think the wireless stays on in the background, and that's what's causing the interference, because if you wait long enough, And there it goes, it just shut off. So yeah, just be aware though, when you turn the thing off, it's still running for like a minute. And this takes us to the EMF test, electromagnetic interference. So let's go ahead and put this here and get a baseline reading. So there you see it, it actually says normal or less than 1. Let's go ahead and put the DC on. Okay, really not much of a change. It went up slightly, but that doesn't really even count. Let's go ahead and turn on the AC inverter. Oh, and of course, we hit 80. That is considered high interference. And it's pretty much all around the power station. Doesn't really matter where we move it. It is pegging 80, which is considered quite high. So if you are in a situation or condition where you cannot have a lot of electromagnetic interference, this inverter gives off a lot of it. So you saw what it did to the AM radio, but then this was at 80, which is pretty much as high as it gets. I mean, I've seen it go higher than that on other things, but power station inverters, 80 is considered pretty high. A normal would be somewhere between 40 and 60. So that does give off more EMF than a normal inverter. And that might just be because it's 3600 watts. It's pretty huge. So you expect it's going to give off more interference. So what do I think about the E3600 LFP? Well, failure of that DC output aside, the 3600 is a pretty solid product that offers a heck of a lot of bang for the buck and puts out some pretty impressive numbers. It has everything most folks need without too much of the fluff. It still offers wireless charging, a feature that seems to be quickly disappearing for some reason. It does have a decent app that works fine, but it still needs some polish. The sound pressure levels are acceptable for a unit of this size. The massive 3600 watt inverter does its job. The triple MPPT controllers allow for some very dynamic solar configurations. It even passed the UPS test using a PC computer, and amp interference is clean enough for most use cases involving audio amplifiers. What was disappointing, of course, was the failure of the DC output on one of the 2 prototypes I had. Now, I didn't have time to run the second one through the same barrage of tests to see if that one was going to fail too, as it literally takes 2 days to complete that test, and this video had to come out this week. So at the time of this filming, Pecron has been notified of the problem, and they told me they are attempting to reproduce it, and they do assure me that they will fix any problem they find before the product ships to you. I do have full confidence they will. Now, how could I say that? Because I don't work for them. Now, Pecron did say they take quality very seriously. So seriously, in fact, they fired the quality control person in charge of testing this unit. As someone who used to manage a QC department at a tech company, I totally agree with that decision because, hey, that person had one job. There are also a few things I think Pecron can improve on. First, I'm not really a fan of the touchscreen. The interface works just fine, but it does lack some polish. Everything's kind of crammed in the weird boxes. The font's kind of weird. It's just, it doesn't seem like it's completely done. It just lacks some polish. Anyway, I do expect that some of this is going to change by the time they ship to customers. There are also no firmware updates available yet through the app, so I'm sure that's going to be coming too. Now, this next one's a minor gripe, but that inverter certainly puts off a heck of a lot of radio and EMF interference. That's really not going to be cool for folks using sensitive electronics around this product. Now, most folks really aren't going to care about that, but it needs to be said. Maybe they could increase the shielding inside to reduce some of those numbers. It does have to be taken into consideration that Pecron is a much smaller brand with limited resources, but they do have a cult following that reminds me a lot of the one that Blue Eddy used to have back in 2019. I wouldn't be surprised in a few years we see Pecron as a major competitor next to the heavy hitters. They definitely seem to understand their customer base and they cater directly to them. And I think that combined with their very competitive pricing is why they have such a cult following. Or it could just be the name. Now, the only reason you're watching this video is product price. Now, they're asking $15.99 on pre-order, which is a fantastic deal. But if you use my discount code, it's going to knock an additional $80 off for a final price of $15.19. This is less than 50 cents per watt hour or 42 cents per watt. I also want to mention that if 3 kilowatt hours isn't enough for your use case, You can expand it with up to 12 additional kilowatt hours of external batteries right now for only $1044. That's $1044 for a 3 kilowatt hour battery. That's a ridiculous 33 cents per watt hour. I don't think any of the other major brands can really touch that amount of value. Now, if you're looking for solar options, Pecron, of course, offers bundles with their own folding panels, but if you're looking for something larger or more robust, since this does support some pretty big solar panels, you can check out my website at hobotech.tv for recommendations, or just check out my solar power playlist here on YouTube. So if you're interested in the E3600 LFP, the link and discount code is going to be in the description of this video below. I'm also going to put a link here on the bottom of the screen along with a QR code that you can scan with your mobile if you're watching me on TV. It's going to take you on over to the Pecron store page where you can check out the E3600 LFP. Thanks for watching. If you learned something today, don't forget to give me that thumbs up below. And if you're not a subscriber already, you know what to do. That's it for now. Till next time.
Odin commands you to like and subscribe, and clean my litter box.
And one more thing. There is nothing more fun than telling your significant other that you're going to go whip out your Pecron and play with it. That alone is worth the price of admission.